Hey guys, and how's it going? Just wanted to go over all the parts we're going to use on this engine. Prior to building it, I like to explain what we're using, why we're using it, and what the goal is, and kind of a little bit about what we're going to do before we start the engine build. So I got the case back from the machine shop. It was already line bored once, and I don't think it had that many miles on it, and we confirmed that over at Brothers VW Machine Shop. That's who does especially 36 horse. I either use Brothers VW Machine Shop, or in Riverside there's a guy, Performance Workshop. He's really good. So either one of those guys, reasonable. He does not do 36 horse, so I took it to Brothers, and the Brothers do excellent machine work especially for 36 horse. They really know these engines well. They're actually a really good machine shop either way. So anyway, so I took it there. They got the cylinders open for 80s. We got new case savers put in, and they installed the case savers for us. What I have to do myself is remove all the plugs here, and here, down here, and whatever, all the oil plugs for the galleries or galleys, whatever you want to call them, here, and then there's one back over here. Remove all these, and then with these old cases, they recommend, Brothers said, you really should do it on this because a lot of times they're really old and they might have oil that's, or dirt and stuff that's stuck in the areas, and it's better just to be safe than sorry. So especially with the kind of money for these parts, we want to make sure that we don't have an issue. So I'm going to go ahead and clean out the case, pull all the plugs, get some brushes, bottle brushes, and then clean it. And it still has a little bit of like oil residue. I'm going to clean all that off really good, and then I'm actually going to paint the case with this stuff, Cerakote. This stuff's really good, but you just have to rough it up really good, and it goes up to, I think, I don't know, 500 degrees Celsius, something like that, crazy high temperature, and it adheres pretty well. But of course, when you do that on these, you gotta mask off everything. You don't want to get any of that inside, so all these holes have to get masked off, and then paint the case and make it look really cool. And this one here is a copper color. I thought it would look a bronze, burnt bronze, so it's gonna look kind of neat. Give it that aged look that we're looking for. And this stuff's really good oil resistance, so hopefully this works out well. This is not just a spray can deal. This stuff's not cheap, by the way. So anyway, for this build, we're using stock rebuilt rods. I got these at a swap meet, a really good price, so I thought, well, we'll just run with these. So you really don't, I mean, a 36 horse doesn't have that much power, so I think these rods, because look at the H pattern they have on these ends and stuff, these are pretty strong. I believe they're plenty strong for the amount of power we're going to give it, so we're going to use stock rods. We're using a 26 millimeter Shattuck oil pump because we are going to do a full flow cover. Okay, I'm not sure what I'm going to do yet with that, if I'm going to run on a spin-on filter. I'd like to get one of those ones, the old ones, eventually. I'll probably do that. So I'm just going to go ahead and full flow it now, and at least maybe I'll just bypass it for now. I don't know. So I'm just telling you that stuff. New bearings, AA Performance. These come from BBT. So the two sponsors on this video, on Fit Series, are Wolfsburg West. Wolfsburg West provided us a really excellent deal on these parts so that we could be able to show them to you. So it's awesome that they contributed a huge amount for this. Same with AA Performance, always, again, they help us out with really low pricing so that we're able to afford to do this. And so these come from BBT, so that's how they come in to the country, or through BBT. So that's where the 36 horsepower bearings, basically there's one supplier that has them. I haven't even looked at them yet, but anyway, so those come from there. So the crankshaft, this is a Wolfsburg West, I believe it's their product, I believe they make it. a lot of their products are outsourced, of course. They like to do business with Taiwan, who makes a whole lot better product than China, okay? Because they've given China money for stuff. I heard the stories over the years, and actually they took their money and they never got their molds back, all kinds of crazy stuff I've heard. So they deal with Taiwan. They have sources over there that do excellent work. So a lot of stuff's made in Taiwan. I didn't see where this one's actually made. This is 4340 chromoly, and it's counterweighted, 69.5 stroke. So they do make a 74, but to do the 74, you run into a whole lot more complications. Well, I was going to make a video on that, about the stage 1, 2, 3, and stuff like that on these engines. We'll be doing that in the near future. But this is kind of like a stage 2 because we're using a 69.5. So we got a new set of push rods, also again made by Wolfsburg West. Excellent sourcing, high quality parts. Tony really goes over the top to try and get everything to be the highest quality he can get, to be the closest to German engineering as possible. So really, to me, his stuff is excellent. So we're going with their push rods. These also may need to be lengthened. We'll find out later. We may or may not need to do that because we may not actually have a wider engine, depending on deck height when we get to that. So we'll watch the video later. I also take these videos and I'll stack them all together and make one video on the full build. And what that's for is so that if somebody wants to look at this engine build, they can watch any of the footage and see the whole build instead of having to go through a whole series of different videos. So watch out for the edit. If you see it and you've already watched all the singular videos, just at least let it run for a while, because we want to make sure, you know, if you go and like the video, appreciate that, that you just let it run for whatever. Just go to work or whatever, let the video run its way through. And the reason you do that, because then it shows more watch time, then the algorithm will actually give it love. Otherwise, a lot of my stuff either doesn't get watched long enough, or it just doesn't meet all the stuff the algorithm is looking for. So if you guys contribute that way, it would really help out. I appreciate it. So anyway, camshaft. Here's the camshaft that they have from Wolfsburg West. Is actually replicates the stage 2 Okrasa build that they did back then. So what Okrasa did is they had 2 kits, I believe. They had one kit that had the 69.5 crank, and it had the heads and stuff that we're using on this. They also had another kit where you just bought just the heads and stuff like that and added them to your stock engine, which gives you, I think, what, 52 horsepower? I'm going to guess. It's either 52 or 54. I can't remember. Here's the cam specs on here. They're really small. So, but if you look at here, these are at 0.050, 227. So I don't really know what the advertised duration is. So we don't really know. And the cam lift's only 345. So what this does is it's a nice spec right here, because you can take this and at AA Performance you can add the ratio rockers. So if I feel like when I get done it doesn't have enough juice, I'm going to hit the ratio rockers and throw them on there, and we'll see how that does. Because they sell the ratio rockers, the 1.15, I think they are, ratio rockers at AA Performance makes them. So I'll add those to it if I need to. But the way I looked at it, this here is a decent grind for this size engine. If you go too big on this thing, it's going to be really, and the stock ones are like, I think the lift on a stock cam is 295, I believe. 295, little tiny thing. So we're going to a 345. That's a heck of a size increase. So that's going to help. And with the big valves, so you have to factor all that stuff in. So if you're using stock valves, you can go with a bigger cam, maybe. With the bigger valves, you may not be able to go too big on because you're going to get so much air and fuel in there, and we want to kind of meet that right place where the air and fuel mixture is just right with the amount of size of the engine we have, and compression ratio and all that. So we have, these are opened up for 80 and 81. Just so you know, if you wanted to go to 80s, AA makes 80s, and you can open it up. It's the same opening for either one. We found that out over at so the cylinders and pistons I have are 81s. So we're going to have a 69 by 81 with the stock, with the actual, the ones that they come with here, the carburetors from Wolfsburg West. Some guys were saying you could upgrade these to have them rebushed. So we may end up doing that later, but we're going to put it together for now with just those. And if the shafts start to wear out on these, I don't know if I'm going to drive it that much anyway, but if they do, then I'll maybe put a video up on rebushing them, you know, which should be done either, you could do it with a drill press probably, or a mill, but you got to have a really straight drill going through there. You can't have it a little wonky, because if you do, it's, you know, that's not going to, that butterfly is not going to close properly. So there's that. So we're going to put on the stock air cleaners, the stock, all the stuff that comes in the Okrasa kit. The way it is, we've already got the tin opened up. The way that you have to do these, and the reason I don't like to go with the other carburetors that you can put on, is you have to put the tin and the manifolds on at the same time. So, and then you put the engine in the car and you can put the carburetors on. So it's not that easy to do. So a lot of guys, because you can't get to this bolt here. If you go inside here, you can see down in there, you cannot get to that bolt anyway to take the manifolds off in the car without the tin. So you have to do the tin and the manifolds at the same time. So the guys that run the like 40s or something like that, it's a lot more work to try and put those on, because you have to kind of assemble everything at one piece in the car, and it's, you know, put all the tin on it and put the oil cooler on it and put the fan shroud on. And so if you can imagine getting the oil cooler bolts on in the car with the fan, you have to have the fan housing kind of in the way. Not easy to do. So that's why this is, to me, it's probably the best way for me. So there's a lot of options, a lot of things you run into doing it the other way. Again, I've never built one of these this way at all. Never really done a 36 horse. So I'm teaching you guys as I learn it. So I might miss a few things. So what's nice is at Wolfsburg West, they have these 81 millimeter pistons that are forged. Okay, forged is much better than the cast piston. They'll take a little more heat. So we may end up getting a little hotter. Depends on what fan I run. I still don't know what fan I'm going to run on here, what will fit in that fan shroud. If I can run something, like if I can run the 40 horse fan or the 1600 fan, the early 1600 fan, I'll probably try and do that versus the 36 horse fan. I'm not sure. I think this one's a 36 horse fan, so it doesn't have very many fan blades on it. So it's this one here, and the 40 horse I believe has twice as many, or more than this, or maybe they're the same. And then the 1600 has more fins. So I don't know if it'll fit. If it will, I'll try it. Which will cost me some horsepower, believe it or not. It'll actually take away a little bit. So I'm not sure. You can always comment below on that. I haven't got to that yet, so we'll think about that one. So again, these heads have larger valves in them, and they're twin port. So this is what comes in the kit. If you guys haven't watched the kit video, these are dual port. You have to cut the tin to get them to fit, and the stock tin, and they the ports are nice and smooth. I don't think I'm going to do anything to these. They're so nice. I can feel they're cast. I mean, I could smooth them up a little bit, but yeah, I mean, they're really, the flow of these is amazing to me. I didn't check this one. Oh yeah, no, the exhaust flow, I can feel it. It doesn't have that hard corner like the 1600 heads do. So these are really well made. I mean, these are really nice. I mean, if this is how the original Okrasa ones were, and they're supposed to replicate them exactly, I can see why you got that much more power out of it. So, because the head flow on these is actually pretty nice. From my opinion, from looking at them, I think they're just super nice. So I haven't machined the heads yet. And again, the reason I haven't machined the heads now is because I want to assemble it, figure out what my deck height is. Because remember, we're got a stroker engine, so we're gonna have a little bit tighter deck height. Definitely gonna have tighter deck height, and the piston might be sticking out a little bit because I got stock length rods. So the piston might be sticking out a little bit. Then I'll figure out how much shims to get. So the only people who make shims for this are Wolfsburg West, by the way. So I got some of those. I got like 2 sets of 20s, and they are not cheap, by the way. But I got 2 sets of 20s, and they did give us a deal. But I'm just saying that, you know, keep that in mind. Some guys will go and take the pistons. I'm like, Brothers Machine Shop does them this way, where they take pistons and they will actually machine the piston down. But, you know, I don't really like to do that. But, you know, what you do is you have to measure the thickness of the piston and see if you can see how much you can take off. Because you have to have a decent amount of piston there, right? So the guys will actually deck the pistons on these and do them that way. So I don't know exactly what I'm going to do yet. Oh yeah, somebody mentioned in the comments that they had got a set of these and these pistons, the 81s, and they have really thin rings and they didn't seat. My question to you is, did you oil the rings when you put the engine together? I talked to several engine builders, and including ourselves, we assemble the engine with the rings dry. No oil on the rings, purposely because that helps them seat. And I talked to several other engine builders, and they say exactly the same thing. It's up to you, but maybe that's why they didn't seat. What's his name? Brothers Machine Shop uses a similar piston with really thin rings, and they don't have issues. They use an 80 millimeter piston. It's not from AA. They have a forged piston that they use. They're kind of expensive, but they have really thin rings just like these. So that's why we're going to try these and see. I don't think we're having an issue, but maybe that's why. Somebody mentioned that they had issue with the rings not seating, and I think that might be the reason why. Dry, you guys, dry. No oil on the rings. I put a little bit on the skirts, nothing on the rings. Put it together. 30 seconds after that motor's fired up, the rings are seated. So that's how that's how we do it. So anyway, you can do what you want. Anyway, talk to you later. On that, maybe I'll deck some of the piston off, and then maybe what I'll also do, what I'm going to try to do, is open these up. That's why, again, I haven't machined them yet. Is open these up for 80s or 81s. Either one, they're the same. So these are 81s that we're using. And I will open this up for 80, 81, and then I will have them step cut. I'll show you. Let me do that. I'll like have them take, I mean, if you look at the thickness on these, thickness is still pretty good on these. It's not like a thin wall 92. It's pretty standard looking. So yeah, there's plenty of meat there. So what I'll do is I'll have them open these up. Now, I'm not sure if the head size needs to be different, so I gotta take these down with me when I go down there. They haven't measured this in. And I'll have them cut these open for these. And then I'll have them step cut the head so that it'll be, say, you know, a little bit wide open, more open, like that much, you know, another 10 thousandths wide open than the actual opening, and then that will ride on the cylinder. And then if my piston's at 0, okay, or at 5 thousandths or whatever, it'll be like I'll end up with a nicer combustion up in the head versus having it fire in the barrel. So we'll talk about that later in the video series on this engine. So again, I don't know what we're going to do there yet. So that's why I didn't have them machined, because I'm probably going to have them step cut them, which will be like a little step Yeah, here's a 1600 fan. Look how many more fins are in there. So, or new, that is a 40 horse. I don't know. Sure is rusty though. Let's see if you guys can see this in here. That's a step cut right there. Okay. That, let me get you up like right here so you can see right there, that's a step cut. Normally this would be flat all the way across, but that little step in there, that's what I'll do, and I'll make sure that that is larger than the cylinder. So after they're done getting machined, I'll drop my cylinders down and make sure I can't see that edge at all. Okay, then I know that my piston is not going to hit, because there is always rod stretch. When your piston goes all the way up, it'll stretch the rod just a little tiny bit, and that, you know, they say deck height needs to be at least like 45 thousandths. So I'll probably tighten it up just a little bit. I might even go to like 45 or 50 instead of 60 deck height. Stock is 60 deck height, so I might go a little bit tighter, and that way I'll end up with a little bit higher compression ratio with those 50cc heads. When I do these engines, I have rough calculations ahead of time. So I've already figured these are 50cc, all right? I know that they're 50cc, I checked them, and I wanted to know, okay, what the procedure is going to be before I start the engine build. So I kind of know that, okay, I got to wait. I'm machining these until after I put the piston in and deck height it, because every engine's a little bit different. I know that on this one I'm going to have an issue with deck height. I know that, you know, that's going to bring my deck up a lot closer with stock rods and a stroker, because we're going from a 64 stroke to a 69.5. That's 64, 5, 6, 7, 8, 9. So 5.5 millimeters. So that's what is that, 2.5 each way, or I don't know. So yeah, 2 3/4 millimeter each way. So, you know, you got to take that into thousandths and try and figure it out, so you kind of know in advance what the problems are going to be. And also I've decked this a little bit. I don't know how much they took off of that, just a little bit, maybe 3 thousandths or so. So all that stuff's going to add up to something, and once we put it together, then we'll know what that is. But kind of got to have an idea before we start to where we're going, so that I know, okay, what kind of compression ratio do I want. I'd like to get to close to 8 would be nice. A lot of guys are saying don't go above 8. I know guys are going to 9 with these old things, and I don't know if I'd want to go that far, that's for sure, because then I'm going to be pushing, running hot. Then I'd have to think about 2 coolers and all that. I don't know if I'm going to go there or not. So, and plus we're going to have a stand-up cooler on here, not a doghouse. So, you know, I'm thinking 8-ish will be a safe zone. So anyway, we'll figure that out later. You're still kicking that around, and if you guys got any input, you've done one of these, tell me what your compression ratio is. If you like it, that'd be great in the comments. I'll be listening to those things, watching them, reading them. So, because we're going to the 8 dowel crank, and that's what's nice about these. These are 8 dowel, so these are stroker counterweighted 8 dowel. That makes a huge difference in the way that engine performs and goes down the road. This thing will take a lot more RPMs, and because we're going with that, we're going to run more RPMs. We're going with a 26 millimeter oil pump instead of a 17. What came in these things, a 17. If you're running one of these and you decide that you want to run it at higher RPMs than 3,000 RPMs, believe me, take the oil pump out. So if you're going to do just this kit, if you were going to just put on just the head kit, I would absolutely recommend changing to at least a 21 millimeter oil pump. Take the 17 out and, you know, put down the ducky and get rid of that one and put in the old 21 at least. Okay, but we're going to a 26 because potentially we're going to put some sort of full flow system on this. I don't know. So we're going to go with a little bigger pump. I absolutely would not put a 30 on one of these. The controversy of that, just so you guys kind of know, if you go too much oil pressure, when you create pressure, you also create heat. So if you build up a lot more oil pressure, then your engine case will handle, which this thing has super small galleries, whatever you want to call them. They're really small, and you start putting, you know, all that major pressure buildup in there, you could end up with more heat. So there's things that you got to be thinking about, and that's what you'll see people say, oh, don't use that one, it creates, you know, oil to get hotter. And some guys will say the oil cooler can blow up. That can happen. So 30 on this thing would be kind of too much. 26 already gonna be pushing it. 21 is kind of the nice setup for one of these, for at least if you're gonna just do the heads. Again, all you gotta do is look at it. If it's real thin, so this is like a 26, right? A 21 is maybe a couple millimeters smaller than this, okay, because I think they put some in the back. But a 21 is a little bit smaller than this, a little bit less thick. But you'll see a 17 is like really thin right here. So you can kind of look underneath your car, look right here and see if you got a 17 in there. I'd just take that sucker out either way, even if you're going to just run stock. Even if you're, so like me, driving down the street with 70, I'm pushing it with a 17. That could blow the, you know, could blow the engine up pretty easily, you know. So 36 horsepower, 40 horsepower, also came with a 17. That's an X-nay to me. Some guys in Europe, they say, oh no, they work great. Well, go for it. You guys keep it in there if you want. That's up to you. I ain't doing it. So anyway, I think that's about, other than the flywheel, I was going to tell you about this too, because this is kind of cool. This is a Porsche flywheel for 356. This is a 6-volt gear. All right, Volkswagen clutch, 200 millimeter flywheel. It's not a bus flywheel. It's a 200 Porsche 356 because it has a small dowel pins and everything, and it takes a special gland nut. So if you order one of these, make sure you get the gland nut. This is a chromoly one. I don't know if they make anything other than chromoly for that, but this is a chromoly gland nut. So we're going to go with the Porsche 8 dowel flywheel, Porsche chromoly gland nut, and it's still 6-volt here. It's 200 millimeter, and it fits on a 36, and it's 8 dowel. So you can add, one of these is really cool, and it's lightened. Because remember, if you go with a counterweighted crank, so if you're just going to go with the stock crank, I would not put this flywheel on. Okay, you need to weight with the stock crank. If you're putting a counterweighted crank on, you're putting the stress and the weights right here. Okay, this crank is a little heavier than the stock one, and that's why guys they really invented the lightened flywheel. That's why the Porsches had the lightened flywheel, because they had the counterweights on the crankshaft. So counterweighted crank, lightened flywheel. I do it every time, even in a bus. People go, what? In a bus you need the weight. No, you don't, because you got the weight right there. It's on the crankshaft. This is fine with this lightened flywheel. It'll still, you won't even notice the difference. I drive my buses with lightened flywheel and a counterweighted crank, and you can let the clutch out. It doesn't want to stall or anything like that. But you put a lightened flywheel on with a stock crank, oh boy, it's gonna, you know, it's like real easy to stall the engine when you let the clutch out. So anyway, that's why they made the lightened flywheels, is to go with that crankshaft, the counterweighted crank. And so, just so you know, I had these push rod tubes that I took out of the engine that were original, and they still have the logo on them, and they were absolutely perfect. I mean, there was the smallest amount of surface rust I've ever seen on these. They almost had nothing. They were coated in some oil, and that kept them surviving all this time, and these things were like mint. So I went ahead and rescued them and kept them. So we're going to run the original push rod tubes. Yeah, you know, they're used. Usually I'll put new ones on a good engine when I'm spending this kind of money on parts, but these ones here were so perfect. I just decided to run them again because they really were just like brand new. I put them in, I took them out, put them in degreaser in the sonic cleaner, cleaned them, and then you could barely even feel any roughness from the rust. I mean, there was no pitting at all and nothing. And I just put them in some rust, what's that called? Evapor rust, and everything was disappeared, and they were perfectly smooth, like a baby's butt, perfect smooth. There was nothing, no pitting at all. Even from the surface rust was so minor. So I figured, well, we'll run those again, see how they do. They probably, and they feel a little bit heavier than the aftermarket ones. So I thought, you know what, I think they're going to be better. Anyway, that should wrap us up. Yeah, I think I've covered everything. I was gonna get a cam blank and have it ground. I decided that the grind that they have is actually probably the best grind. I looked around different things and I couldn't find anything that worked better. So that's why I'm going with the cam that they have. I have a cam grinder that can make any profile. So I could have done that, but I'm just gonna go with this setup that comes with it because it seems to work pretty good. All right. So anyway, that's it for this, guys. I hope it helps you figure out why I'm doing what I'm doing, and I'll talk to you guys in the next one.